here we want to look at domain, and the function has a square root in it. We'll think, what kind of numbers can I take the square root of? Doesn't even have to work out nicely, but I'm allowed to take the square root of any positive number, right? Like, even if it doesn't work out evenly, even if it's not a perfect square, like square root of 4 is 2 is nice and easy, but this is 1.4 something something. So I can do that. I could take the square root of 0 would be 0. But notice if I'm dealing with negative numbers, what kind of things can I not take the square root of with real numbers? I can't take the square root of negatives, because if I square something, it would automatically be positive. So if I'm thinking about the domain, all I need to do is say, well, the part under the square root, no matter what it is, no matter how much stuff is under there, needs to at least be greater than or equal to 0. It can be equal to 0, because like we saw, we can take the square root of 0. And so then I'll try to solve. Maybe I'll add 5x to both sides so I don't have to deal with it being negative. And divide by 5. And notice this opens towards the 9, so if it's saying 9 is bigger than x, then x is smaller than 9. So what kind of numbers work here? So as long as x is less than or equal to 9, we'll make a filled in circle because 9 could be included in that. Alright, so if I want to write an interval notation, having the graph usually helps with that, because I can see, oh, my smallest number goes down forever, so I can take numbers from negative infinity all the way up to 9, and I want a bracket to show that 9 is included in that. So whatever's under the square root has to be greater than or equal to 0. That determines what kind of x's you're allowed to plug in.